In this video, let's talk about the antenna violations. So antenna violations occur during the fabrication step and more specifically during the BEOL step of fabrication, which involves the creation of the vias and the metal layers above the transistors. More specifically, antenna violations occur during the dry etching or the plasma etching step of the fabrication. In one of the previous fabrication videos, we had seen that etching is used to remove any unwanted material from the wafer surface. So in this case, let's say we have a mask here. So to remove any unwanted material like this from the wafer surface is bombarded with plasma, which is highly energized ions, and this helps us in removing any undesired material from the wafer surface during fabrication. So this is called plasma etching. Now, with this understanding of plasma etching, let's try to understand the antenna violations. So let's start with the basics where we have two back-to-back inverters. So the input pin of any cell in our design will be connected to the gate of the transistors, and the output pin of any cell in our design will be connected to drain of the transistors. So if we take a look inside these inverters, the output pin of the first inverter is connected to the drain of the PMOS, which is also the drain of the NMOS, and the input pin of the second inverter is connected to the gates of the PMOS and the NMOS. So input pins always mean the gate of the transistor. Now let's try to look at how this circuit looks during fabrication. For simplicity, we will only look at the NMOSes N1 and N2 and how they get connected to each other during fabrication. So when we start the BEOL step of fabrication, the transistors are already formed, and we start by depositing these contact vias first. This step is followed by etching to remove any other unwanted materials from the wafer surface. In the next round, we deposit the first metal layers like this. This step is again followed by etching to remove any unwanted materials from the wafer surface. During this plasma etch step, the metal which is not removed also ends up accumulating charges from the plasma like this. Now, since the upper metal layers and vias are not created yet, this accumulated charge only has one way to discharge itself, and that is through the gate of the transistor. And while discharging through the gate, it ends up damaging the gate of the transistor, and we lose the functionality of our transistor because the gate is damaged. This is not a problem with the metal which is connected with the source or the drain terminals, because source and drain are the natural current conducting paths in our design, and any accumulated charge can easily discharge through source and drain to the substrate which is biased. So this floating or exposed piece of metal which is connected to the gate is called antenna. And if this exposed metal is bigger or longer, then more charges will be accumulated on this metal, and there are more likelihood of antenna violations or gate damage during fabrication. Next, when the upper vias and metal layers get created, then the drain to gate connection becomes complete, and the gate cannot be damaged anymore because now we have a discharge path through the drain of the NMOS. So as we just saw, antenna violations occur during the fabrication step. So how do we identify or fix any potential antenna violations during our physical design flow? And the answer is that the foundry provides us with a tech file which defines the antenna rules for that technology node. Antenna rules simply state that the metal area divided by the gate area should be less than a particular number, say 500 in this case. So let's take a wild assumption here that the gate area is 1 micrometer square, and the metal which is connected to this gate has a width of 1. Then based on this antenna rule, we can say that the length of this metal should be less than 500 micrometers. Otherwise, there is a potential risk of antenna violations in our design. So we read these antenna rules into our physical design flow as an input. And based on these rules, any potential antenna violations in our design will be flagged to us, and we can fix those violations using one of the two most common fixes for antenna violations, which are metal layer jumping and diode insertion. In the next video, we will discuss how these fixes are done and what are the pros and cons of using each of these options.